Hello friends and welcome to Mathematics Galaxy. So today we're going to discuss about a problem which is very difficult but maybe not difficult. So this is a problem from Singapore Mathematics and the problem is this. So let me write something. So this is actually a definite integral and of course it is definite. So the thing is like this. So integration over 0 to 1 and minus 1 to the power x dx. So this is actually the problem here, and as you can see, so here the function which is to be integrated, which is called the fx. So what is fx? Fx is minus 1 to the power x. So this is fx, okay, and so we need to integrate. So at first when you see this problem, so what comes to our mind? That this is not integrable, but of course you can see that this function fx has some definite value and this can be integrable, okay. So to integrate this function we need to pray for something, or we need to bring out something else from other world. So that is called the Euler's identity. So let me know you what is Euler identity. So Euler identity is like this. So e to the power ix is equals what? Cosine of x plus I into sine of x, where x is any real. This means x belongs to the real number system, and this is e to the power ix. So here, so this minus 1 right here, this minus 1 should be replaced by this equation. Of course, on the left hand side e to the power ix we cannot generate minus 1, so we can generate minus 1 in the right hand side. So the question is how. So of course the part of I, this means what is I is the imaginary number which is called the square root over of minus 1. So of course if you see the right hand side, the I should be deleted, and the only way we should delete I, and the only way we can delete I, is by equating sine x to the 0. So sine x is 0 normally on 2 points. Of course there are so many points, like the points of n pi. So normally sine x is equals to 0 on n pi, okay, but we normally talk about principal values today. So the principal values where sine x is actually 0 is of course x equals to pi, okay, and of course x equals to 0. So let's talk about e to the power 0. So e to the power 0 equals to cosine 0 plus I into sine 0. So this means 1 is equals to 1. So this doesn't give any kind of intuition to solve the problem. So what we need to do, we need to put the value of x is equals to pi. So let me see what really happens. So e to the power I pi equals to what will happen? So cosine of pi plus I and sine pi. So sine pi is equals to 0. So on the next line we're going to write e to the power I pi. So what is the value of cos pi? As we know that cos pi is equals to minus 1. So minus 1 plus I into of course 0. This implies e to the power I pi is equals to minus 1. So we need to replace this minus 1 into this integral right here, okay. So let me see what really happens. So what was the integration? The integration was minus 1 to the power x, of course 0 to 1 dx, and what we're gonna do, we actually put this value right here, 2 minus 1. So then what happens? So of course 0 to 1, and where in instead of minus 1 we're gonna write e to the power I pi whole to the power x dx, okay. This is what happens. So now we're gonna integrate it. course e to the power I pi to the power x, this means this is just a normal rule of index. So e to the power I pi x into dx. Okay, so what is the integration of e to the power ix? So the generalized, okay, so the generalized value, let me write on the right side. So e to the power x integration dx is equals to actually e to the power x, and the other rule is this: if there is e to the power ax dx, what this gives? This gives 1 by a e to the power ax. Okay, so this is the, of course this is the indefinite integral, so we're gonna use that there. So from this we're gonna write like this. So of course e to the power I pi x from 0 to 1, of course this will be written and divided by, of course, I pi, because I pi is here the constant, or you can say I pi is actually a from here. And then if you put the value, let me see what happened. So e to the power I pi, of course x equals to 1, this means it is 1 divided by I pi, minus, as you know, 0, this means e to the power I pi into 0 divided by I pi. So that part is definitely gonna be 1 by something. Okay, so of course e to the power I pi. So what is e to the power I pi? So e to the power I pi, again from this position you can write that e to the power I pi is equals to minus 1. Okay, so minus 1 by I pi, and of course this is e to the power 0. E to the power 0 means 1 by I pi. So from there 1 by I pi, of course minus 2, and this means minus 2 by I pi. Okay, so now, so we can multiply minus 1 in numerator and denominator, then what would happen? 2i by, okay, let me see, minus 1 pi, this is gonna happen, and then from there, what is this? Minus minus, we can cancel it, then it would give 2i by pi. So this is the solution of this beautiful mathematical problem by Singapore mathematicians. So we started from here, okay, and we went right there, 2i by pi. Okay, so this is how normally mathematicians solve problems, and this is how these problems, this is I would say very not difficult problem, but very intellectual problem for graduation students, and of course for joint entrance students who are preparing for joint entrance or MIT or master's exams, master's entrance, or any kind of mathematical entrance examinations, or even WBCS, and of course any kind of CAT, MAT, SAT, or even school service commissions or something like that. Okay, so this is what, and you have to remember that what is the beautiful equation here. The beautiful equation, you can pause this video and you can find out. If you can find out, then you are great. So this equation was given by Mr. Euler. Euler is a German mathematician, Leonhard Euler. So this is the equation, and this is called the Euler's identity. Okay, so if you cannot see clearly, then let me write it clearly. So Euler's identity is like this: e to the power I pi plus 1 equals to 0. So this is called the Euler's identity, and this is very beautiful equation. Even scientists like Richard Feynman, who even hails this equation, he said this is a jewel for engineering mathematics and engineering physics, and of course mathematical physics, and even some topology ideas like that. So here E, I, and pi and 1, there are 4 very different kind of situation, and if you accumulate them like this way, then they would actually generate 0. Of course 0 is 0, as we know. Not always 0 is bad, but 0 sometimes is very good. Of course this is nothing, this is just a scratch. So e to the power I pi plus 1 equals to 0. So this is called the Euler's identity, and this is very important to solve this, I would say, great problem. Okay. So thanks for watching, and of course let me know what you really like about this problem and whether you find any kind of difficulty while solving this problem. And of course like and of course share this video if you will like much more, and of course if you are new then please subscribe, and of course do calculus every day, mathematics every day. Stay safe, and of course thanks, and see you in my next video.